Hi everyone. So as they announced me, my name is Piperevski and I'm a hacker. Are you a hackers? Yeah? Yeah? Great. How many of you are black hat hackers? Okay, there's a police guy out there, so check in there, okay? Just kidding, you are safe here, no problems. So I work as a hacker, but an ethical hacker, so I don't do anything bad so far. It never knows. My work as a penetration tester goes under my company name, Piperevski and Associates. We are a little team from Macedonia, my country, where I live and work. But we don't focus only on projects in my country, work abroad, of course. This presentation will be focusing on hacking attacks, the power of IPv6 driven malware. In my spare time, I like to do some research and to develop a new malware. So in 2010, I first created my undetectable Trojan, undetectable malware, which was very good because no system was able to detect it. And I started to upload samples of my malware to VirusTotal, and still my malware remained undetectable. Even the sample is at the analyst PC, of course. And after a couple of years, I mean in 2014, so about 4 years later, we've come to a point that my malware is detectable. So it took 4 years for the malware researchers, for the analysts, to discover that the file that was uploaded is malware and to create that signature for detection. But of course, we evolve. So I've created a new way of function for my malware, and that is the use of IPv6 and the way of dividing the dropper and the payload. So a little question. What's your favorite malware? How many of you want stealth malware or have a favorite in stealth malware? No? Okay. Do you have your own malware developed? Yeah, one? Just one? Okay. Great. So you're in favorite of your malware, yeah? Great. So I have here a little present for you. You can pick it up later. This is quite interesting logic cube to develop your skills more and more, to think of new ways that malware could function. It's great. Okay. And I have one more question. Which statement is false? I will give you about 3 seconds to read all of these statements and say which one is false. Okay, which one is false? E? E, yeah, great, E. So E is false, definitely. Which means that this is a community and we are not attacking ourselves. We are not spreading malware, unlike the commercial. The commercial conferences are quite interesting. A lot of guys want to attack other guys. Vendors are fighting between themselves. But here in the community, there is no spread of malware, of course, because we are the good guys here. Yeah. Let's talk about malware news. So we all know that advanced detection by the antivirus vendors is happening, yeah. And the malware developers are fighting against it with developing that artificial intelligence that traps inside the malware, which automatically discover the ways that the advanced protection work at the vendor software. And when they discover it, they immediately shut down the malware. So the malware detection will not be able to identify it and to create a signature for that malware and to identify how that malware is functioning. The other thing is that the news nowadays has this one-time malware, which means that we have these cyber weapons developed only for one-time use. So a lot of government agencies are using it. It's not taboo, but it happens. It happens. Then we have this malware as a service, which we have this commercial malware like ransomware. For example, you can generate your own ransomware malware and then get a subscription online via darknet and then propagate that malware and then just collect your bitcoins. Of course, you will leave a little bitcoins for the developers in the darknet, but it's also something new in malware world nowadays. So my malware before in 2010 was developed mainly around this XOR algorithm, which was trying to make the code a little scrambled, so no detection will be possible for the signature of my code. So each time I generate a new malware with that procedure, with the XOR algorithm, the malware was completely undetectable until it was analyzed by the malware analyzers from the security vendor companies. But next time I developed a new and used the same procedure, and again it was completely undetectable. The powerful format for spreading malware on Windows operating systems is the MSI format of that executable. Why? Why MSI is powerful? Okay, how many of you know that? Why MSI is powerful for spreading malware?
Because it can install silently.
Maybe, but that's not the correct answer. Okay, the others? Well, there is a user access control in Microsoft operating systems. And when you trigger execution of MSI, the execution automatically pops up the window. Do you allow user access control? Ask you, do you allow execution of this? And automatically that user access control, if the user says yes, is bypassed by the malware. So then we don't have to escalate the privileges in a way that to exploit a vulnerability in Microsoft operating system is very easy. Without user access control, you can easily get into the kernel land. So that's the MSI. So that's why MSI is so powerful, and MSI malware on Windows operating system has that capability of getting one step beyond and not enlarge the code with the specific shell code for escalation of privileges or bypassing the user access control. So since 2010, I send that malware to VirusTotal all the time. I generate new version of my malware using the XOR and send it, and it's completely undetectable, and then again generate and send it, it's completely undetectable, and in a couple of years they started to detect it, but only the samples that I have sent. And when I generate a new sample with a XOR algorithm, completely undetectable again. Since 2014, in 2014, advanced detection was implemented in several antivirus engines, and from then they successfully detect the several techniques that are inside my malware with a XOR algorithm. So in 2015, it's detectable. Let me show you. So this is my malware uploaded, my old malware sample uploaded to VirusTotal 1 year and 3 months ago. So the result is only 10 antiviruses out of 57 are able to detect it. And I will scroll down just to point out, you can see which vendors detected it, but let me scroll down just to show you that one of the interesting big vendors are on the list that are not able to detect it. So this is Kaspersky. This is Malwarebytes. I'm not saying that these vendors are not good, but I just mentioned that they don't have this detection, advanced detection inside yet. So what's new? How my malware works now? So last year I started a project to develop a new malware that can function completely undetectable, and it can try to exploit something that nobody else has. So it's an IP version 6. So how many of you use IP version 6? 1, 2, 3, 4, 5. Okay. Use global IP version 6, yeah? Okay, great. So nice to hear that. Nice to see that the use of IP version 6 is enlarged, because on previous conferences, the IP version 6 usage, people that get their hands up, was 0. So hope that next year it will be maybe all of you that you will use IP version 6. But let's get back to how my malware is using IP version 6. So I've analyzed that what is the element that can be used in IP version 4 and IP version 6 and be exploited by the malware. So it's a DNS, so dynamic name, the protocol that resolves the DNS queries to an IP address has this new resource record. It's AAAA, which is getting the IP version 6 address to our PC. And I have seen that the IP version 6 address is quite big. So I have come to an idea to get inside the IP version 6 my payload. So it means that the dropper, the part of the malware that's executed on the local machine, on the machine that you infect with the malware, is, let's say, regular document, PDF, exe file, MSI, you name it. There are a lot of ways how to propagate the dropper, but the point is that the advanced threat detection by the antivirus vendors are focusing on the payload. And what happens when the dropper is there? There is no payload inside. And there is a way for the dropper to get the payload. Of course, if we use HTTPS, in short time, it's very easy to for security vendors to identify our malicious servers that propagate the payload. And of course, in some situations, we might be limited in communication way. So the firewall blocks all the communication except DNS. So that's quite interesting, except DNS. So it means that the host that's on the internal network that's compromised with the malware dropper can do resolution of DNS records and then get the IP version 6 addresses. Of course, it cannot communicate with them, but it will get the IP version 6 address. So I've come to an interesting concept of getting that IP version 6 addresses to be the payload. So then I've come to a situation how that payload will be executed and to stay undetectable. Of course, in Microsoft operating systems, the run to fight against Linux, they have developed the PowerShell. So the PowerShell is very powerful, yeah, definitely. I agree, I use it, and so on and so forth. But the security around PowerShell is very poor. So it means that if you use PowerShell for hacking, you can easily bypass a lot of security measures that Microsoft has, that antivirus vendors software has, and then stay undetectable. So I've come to an idea that the payload that will come through an IP version 6 address will be translated into the PowerShell execution code. So it might bypass in that way all of the other security measures that we have on the systems. So how this exploitation happens, on this slide here, you can see that the IP version 6 address is quite big. So if we get the IPv6 address divided into a code that looks like shellcode, then that shellcode could be executed. But the other way, if we get the real shellcode, not this one, this is just an example for the one direction, but if we get the real shellcode, translate it into an IPv6 address, and then we can get that into a resource record on the DNS server, which will be serving that IPv6 address on DNS queries by the malware dropper. So this is a shellcode. This shellcode is simple shellcode execution of calculator and Microsoft operating system. And as you can see, it's quite big. We have shellcodes, of course, that can be smaller, but this is just pure for the example. It's translated into 16 IPv6 addresses. So you can see the IPv6 addresses on the right side. And in first look, they are completely okay. So they don't look like something suspicious or something that points out a malware. So there is no regular expression by the network intrusion detection systems that can detect these IPv6 addresses that present a malware and so on and so forth. And of course, we can get additional step to scramble them if the intrusion detection systems develop that regular expression. But that's for the other conference next year. Okay. So what happens, the first part, how the malware is functioning is that, of course, the dropper is executed on the victim machine, and it sends a DNS queries for AAA records in order to retrieve the IPv6 address. Those queries are able to be executed even on internal systems on which you don't have internet access. Why is that possible? Because every system has a DNS server. So internal systems like military systems, for example, have internal DNS servers. So they are able, those internal DNS servers are able to resolve to an IP address and to give that information to the internal host, which have no internet connectivity. And this is not something new. So there is a malware which functions through DNS. It routes all the traffic through the use of DNS packets, but this is new in a way that the IPv6 address is used to deliver the payload into the dropper. So then after receiving the IPv6 addresses as a reply to the DNS queries, the dropper converts those IPv6 addresses into a shellcode. So this is the shellcode. So automatically, we are able then to execute the shellcode. But now we come to a situation that there are security measures that Microsoft have implemented, Microsoft operating systems have implemented inside, so we need to bypass them. And here comes that PowerShell that I was talking about. So we convert that shellcode for PowerShell injection. So you can see the PowerShell command. And it's having this attribute hidden, which means that there is no option for the user to see that this is executed on his host. And then, after execution of that PowerShell command, we have this calculator pop up. So it's quite easy, it's quite straightforward. Anyway, let's try to show this in action, how this looks like. Yeah, finally. Okay, so yeah, we can hear. Great. So what I have here is great. Yeah, I have a Zoom it. Don't worry. What I have here is my executable. So I have created this my malware exe file. It's available on GitHub in binary version. Hope that I will have enough time to filter out and create that Python code in good-looking form and publish it also in GitHub. So my malware has these input parameters. It says number of URLs, number of frequently qualified domain names to resolve. It's 16. So that's the number of IP addresses. And then we have this this number 1, which is 1 or 0. 1 means that use an external DNS, which follows the next parameter. And if we have 0, then it should not follow this parameter anymore. It will use the internal DNS server that is set up through the network configuration via DHCP or manually. And then we have all of this frequently qualified domain name URLs, which will resolve to an IP version 6 address. They are set up on my DNS server, of course, for educational and testing purpose only. So that's why the shellcode behind those IP version 6 addresses is only the execution of calculator. So they could not be misused for something else. And do you have a problem with the authorities? Yeah, with the authorities, yeah. Okay, so let's execute and see what happens. Okay, I think that we have a problem maybe with the internet. Let me check. Yeah. And yeah, now we have internet. Great. So let's execute again. Okay, so it should pop up. Yeah, here is it. It's the calculator. Yeah, great. So I previously executed it and captured the DNS packets just to see how they look like. So I have here the, for example, this one. This is the DNS query here. You can see that it goes to the public DNS of Google, 88888, and the query goes for av to piperevski.com. Type AAAA, and the response back has this. What? Sorry. Here's it. So the response back, here's the answer, is this IP version 6 address. And yet no antivirus or let's say network intrusion detection system is able to detect with regular expression is this IP version 6 address valid or invalid in order to drop the packet. But I hope that they will create that signature in time, because this is quite new technique. No malware since I have developed this technique is up in the wild using it. But of course we are here, so you all know now. So maybe you will use it, and then the security guys at the network intrusion detection system vendor companies will have to develop that regular expression. So, but just when you use it, don't use it in unethical form. Only ethical. Only attack yourselves. Okay, great. Okay, great. So, any questions so far? Yeah, one question. Sorry, just a second for the mic. Wait for the mic, please. Thank you. No, no, no.
The idea is that you go there. It's already fresh. Hi. Question. What about using DNS TXT records instead of A records?
Yeah, you can use that also, but TXT records are into the network intrusion detection systems analyzed in detail so that they have that rules.
Encrypt them like also maybe.
Yeah, but then it will be suspicious.
Okay, true.
It will be suspicious, and when you resolve a DNS in IP version 6 address, let's say that we have these mobile devices. In 2015, we have, I don't know, I think enlargement of 200% of usage in mobile devices, and they all support IP version 6 function on IP version 6. And what happens? They all do the queries for the IP version 6 addresses.
Yeah.
So we cannot prevent that, but we can let's say we cannot prevent, but we can use it in a way that our malware can function on those devices, because the dropper does not have to be on Microsoft operating system. It can be an APK file, so it can be definitely also an executable on Linux.
Yeah.
So it's a platform independent. It's a mechanism of communication that is platform independent, and of course you can easily exploit the IP version 6 into an shellcode and then get what you want to get with your malware. Of course, yeah. If it is functioning as a ransomware, then you can get it to encrypt, or in some cases even the fully qualified domain name can be used to send a message to the attacker. So the attacker, when he receives that on his DNS server, he will be able to know what he is dealing with. Is on the other side Windows 7, Windows 8, 8.1, 10, and so on. Or is some server or some Linux, I don't know.
Okay, maybe another question maybe, how would you spread out? Would you spread out the domain names being queried? Because here you had just one domain with different subdomain, which is also suspicious. Like.
Yeah, next year on BalCCon 2017, feel free to visit my lecture again. I will have malware as a service.
Oh.
Yeah, where I will use the public DNS. Yeah, it will be interesting for demonstration.
Okay.
Of course, I'm not selling it. It will just be for educational purpose.
Concept, yeah. Okay. Thank you.
Welcome. Okay, some other questions? Yeah. Some volunteer to spread the mic around, so...
Yeah,
okay.
I wanted to ask, where I work, we use something like passive DNS, log DNS requests. Where can we find this sample to run it?
Yeah, it's the sample, the executable is on GitHub. So this is the github.com/Piperevski. IP version 6 malware is free, so you can download it. Of course, the syntax is that the one that in README is, yeah. Okay, some other questions? No questions? Okay, let's trick. The next guy that will ask a question will get these sunglasses. So these are from Alien Vault. It's quite interesting if you are going on techno parties, or I don't know, any kind of parties. Has this, let me open it. Yeah, this one. So next question. Okay, great, here we go. Great.
Actually, I don't have really a question. I just wanted these cool glasses.
Great, great. Well, it looks good. It looks good. Definitely, it has if you press it again, additional modes, so it can be light. Yeah, this is greater. Yeah. Great. Okay, next question. Well, I don't have any glasses, but I have something else. Yeah. Next question. No. Are you sure? Yeah. One more. Great.
Sorry, it's off topic, but it's about the classes. Anybody tried to replace the alert by infrared to fool some face recognition?
Interesting, interesting. This is for your question. Yeah, you can pick it up. And this is an interesting logic cube, and you can try to solve it and think outside of the box like any hacker. Great. Next. I don't have any awards anymore. Yeah.
Have you thought about implementing the dropper in JavaScript or something to be delivered through web pages?
The dropper.
Yeah.
Yeah, well, you can use a classical, representation of a picture in JavaScript and get the use after free as a payload. And then because it does not have any malicious shellcode inside, then it executes only the subroutine for doing the DNS queries, and then it will get that shellcode through the IPv6 addresses. And that's an interesting way to propagate the dropper there. Definitely great. Okay, if there are no more questions, thank you. Hope that it was interesting and fun. And of course, see you next time. Thank you.